So I'm going to take the first session on the independent sample t-test. So this independent sample t-test, again the same thing which we have learned for the past 2 days. The basic concepts we learn first, then followed by the research questions, then the assumptions and hypothesis, what are the commands and interpretation, and then at the last we will summarize the commands. So this independent sample t-test, as the name says, so first term is independent. That means the groups here are independent groups. And yesterday we learned about the concept of independence of observation. So this independence of observation assumption holds true here also. So in this case, there are two groups, and in those two groups, there is an independence of observation. That's why we call it as a two independent group. That means if you have counted one person in one group, that person will not be counted in the other group. And t-test, because here we are comparing the mean value of a continuous scale. So in this case, this dependent variable is a continuous variable or a scale variable, and which we measure its value across the levels of a categorical variable. And the categorical variable should have only two levels, because if it has got more than two levels, then we do the ANOVA, one-way ANOVA. So since we are doing the independent sample t-test, so we will be having a category in which it will have two levels. So what are the research questions to answer which we need independent sample t-test? So in this case, the first question could be, is the average BMI value, BMI is the body mass index, of population with history of cardiovascular disease is different from the population without history of cardiovascular disease? So in this case, you can see here that this BMI, it is a continuous variable. And this cardiovascular disease status, this is a categorical variable having two categories. And the second category is with cardiovascular disease. The second research question could be the comparison of pain score on visual analog scale after surgical technique 1 versus surgical technique 2. So again, the continuous variable here is the pain score. So pain score is a continuous variable, and this we are assessing this continuous variable across two type of surgical technique. The first is surgical technique 1, and the second is the surgical technique 2. The third type of research question could be, do medical undergraduate students who have good quality of sleep score high in exam as compared to the poor quality of sleep? In this case also, you can see that the percentage of marks obtained, it is a continuous variable, and the two levels are the good quality of sleep and the poor quality of sleep, and these levels are of a categorical variable. So in all these research questions, what have you observed? So we have seen that scalable in each research question, and I want to assess the mean value of this continuous variable across two categories of a nominal variable. So the right test for such type of research question would be the independent sample t-test, which is also known as the student t-test or unpaired t-test. So it is also known as, the other names of this independent sample t-test is the student t-test, between subject t-test, and unpaired t-test. So basically, there are three research designs in which we can apply this type of test. So the first is when you have to see the mean difference between two independent groups, like we have seen in all the first three research questions. In this case, you can see this is a table. There are males and females. This gender, two type of gender is there, and this is the value of cholesterol. So if I am comparing the mean cholesterol level in male and female, then again this type of research design is one research design where we can apply independent sample t-test. Second type of research design could be, I want to see the mean differences between two interventions. In that case, you can see this group has been categorized as intervention, and control. So this intervention, it has got some cholesterol level and the control has got some cholesterol level. So the blood cholesterol was measured again after 6 weeks of exercise training program in intervention and control arm. And if you want to do this comparison of these two values, the mean values, then you can do the independent sample t-test. The third type of possible research design could be if you want to measure the mean difference in the change score. Like for example, this is the intervention group and this is a control group, like we have seen in the second type of study design. And in this case, you can see that there is a pre-cholesterol, means before intervention, we have measured the cholesterol level, then we have done the intervention, and then we again measured the cholesterol level. So in this, there are two groups, and we have measured the cholesterol level twice, before the start of the study, before the intervention, and then after the intervention. So there is a change score, pre-post. In this case, you can apply paired t-test also in the individual group. But if you want to measure the change score, change in which group is more, then in that case, again, you have to apply the independent sample t-test. So just to revise, we can apply this in the three scenarios. The first is the, again, two groups. And if you want to see the mean value of any variable across these two groups. The second is across two intervention. If you want to compare the outcome value of any continuous variable, then you can do that. Or if you want to measure the change score, like it's a pre-post study having two groups, maybe a RCT or maybe a group with a control group, then again you can do such type of independent sample t-test. So there are some underlying assumptions which are very important. And in this case, the first assumption is there should be one dependent variable which should be continuous in nature. There should be one independent variable which should be a categorical variable, having two categories. So it should be a dichotomous variable. And the third could be, like again, we have read about this because the term says independent sample. So in this case, there should be independence of observation. And we have to ensure, and this independence of observation, we cannot check it objectively in SPSS or in GEMOVI. It's a study design issue. That means you have to ensure that if you have taken participants in one group, those participants will not be counted in the other group. And the fourth assumption is the dependent variable should be approximately normally distributed across the levels of the independent variable that we check by the QQ plot, or if the sample size is less, we can do the Shapiro-Wilk test. In this case, normality testing in this SPSS, because we are not doing, so I'm just leaving this because we have done this in GEMOVI also. So now there is a concept of normality for t-test. So in case of an independent sample t-test, it is a robust test. So if there is a slight deviation for normality also, even then you can apply this test. So that's why we call it that the data should be approximately normally distributed. It should not be, it should be, wholly or fully normally distributed. If it is a slight deviation from normal distribution, still, because t-test is a robust test, you can apply this t-test. The second thing is, as you increase the sample size, because the central limit theorem, it says that the data tends to be normalized. I mean, it has a normal distribution. So if you have got a fair large number of sample size, then again, you can apply this t-test, that is the independent sample t-test. And if the distribution in both the groups are in same direction, like we will read that if there is a skewed distribution, ideally you should apply Mann Whitney U, which is the non-parametric analog of this independent sample t-test. But if you choose not to do that, because in this Mann Whitney U, you have to compare the median value. So if you want to compare the mean value, and if you want to apply sample t-test. And then there is another assumption that is about the outlier. So we have done this outlier. How do we check for the outlier? Yes, you can type in the chat box. How do we check for the outlier? So we check this outlier by the box plot. So there should not be significant number. Again, this we have to be cautious with significance. So like if there are 4 or 5 outliers, it depends on the total number of sample. So if you have taken 100, 200 samples and there are only 4 or 5 outliers, those are not very significant. So you can take a call to either include them or to remove them depending upon your choice. And then, but again, there should not be a very much significant number of outliers. Then there is another assumption, which is so this is again the outlier testing. We have done this, that box plot. If it is a normal outlier, it will be like a dot. If it is an extreme outlier, it will be in a star. But this is in the SPSS. In JAMOV, it is only the dot which you see. So there are reasons for outlier. There is a data entry error. It can be a data entry error because when you enter the data, there can be some error while person is entering the data. There can be outlier. It can be a measurement error, like the machine or the instrument which you are using, it is not validated and you have not standardized it. It may give some outlier, or it can be a genuinely unusual value. So how to tackle with the outlier? You can, if there are many number of outlier, you can apply Mann Whitney test, which is the non-parametric analog of the independent sample t-test. You can modify this outlier with the one value which is the less extreme. That means you can arrange the values and you can say that the highest value, there will be values which are just below that the highest one. So you can replace that highest value with that value which is one value lower than that, or you can transform the dependent variable. So transformation, we generally do the log transformation. So you can do that, or you can include the outlier and run the analysis. So whatever you do, it is up to you. But we usually say that you should report the outlier. And because t-test is a robust test, you can go ahead with the independent sample t-test. Then the sixth assumption is that there should be homogeneity of variance. So what do we understand by this homogeneity of variance? So we have learned about this variance in day one. Remember, we say that variance is the sum of squares divided by total number of sample. So the sum of square was we remember, individual value, we deducted the individual value from the mean value, we squared them, and then we had sum of those square divided by the sample size minus 1. So that is the definition of variance. Now in this case, assumption is, because this independent sample t-test, you assume that the two groups which you have made in your study design, you have recruited them from a population. So the population variances from you have where you have recruited this individual, they are same. So it runs on that assumption, and that we check by the test which is known as the Levine's test, and this is the homogeneity of variance. So we assume that both the variances should be equal, then only we can take the value of student t-test. And we learn when it is not there, then we have to take some other value of t. So in this, whether it is SPSS or it is this JAMOV, we test it through the Levine's test of equality of variance. And in this case also, the p-value which is there, it should be like the Shapiro-Wilk. Here also the p-value, we don't want the p-value to be less than 0.05. Because if the p-value is less than 0.05, then we can say that it is then we can say that it is, equality of variance is met. So when the p-value is more than 0.05, then we can say that the equality of this homogeneity of variance, it is met. That means the variance in the two populations from where we have withdrawn the sample, they are equal in number. So this JAMOV, again, just forgive us for this repeated term of. So yes, can we delete the outliers? Yes, you can see, it depends on the number of samples you have. Like if you have total number of samples 50 or 60 and the outliers are 20, then I would ask not to delete them, because then your sample size will be very less. It will be like 30 or it will be 20. So it depends on the number of outlier. If the outliers are few, you can remove them. But if outliers are many, and that many, there is no objective criteria like, 30%, 20%, 10%. But if you think that there are significant number of outliers, it is better that you include the outlier and do a non-parametric test. But again, if the outliers are like 5, 6, 7, as compared to the total sample, if you have taken like more than 100, 150, then the removal of outlier. But again, once you remove the outlier, you have to do the normality testing and again, because it is not a short thing that if you remove the outlier, then the data will be normally distributed. There can be a scenario when you have removed the outlier, still the data will not be normal. So you have to do the assumption testing after removing the outlier. Is it okay? Then this Jamovi also, it has got two options of T statistics. There is a Welch statistics and there is a student T statistics. So this first, when the this assumption of equality of variance, this is met, then you should apply this student T value, which we will see in the Jamovi option, and its degree of freedom and p-value. When the equality of variance is not met, that means there is an unequal variance. That means the value of the p-value of Levine statistics is less than 0.05. Then we call it as of unequal variance. And in that case, we use the Welch T statistics, its degree of freedom and its p-value. So remember, if the data is not normally distributed, because there are many assumptions of this independent sample t-test. There is an assumption of outlier, there is an assumption of normality, there is the assumption of equality of variance. All these options are there in Jamovi. Only thing is that on the basis of the values of these two, like QQ plot and Levine statistics, you have to decide whether you are going to do a non-parametric, or if the value of this Levine statistics is less than 0.05, in that case, you have to take the Welch statistics. So now what is the null hypothesis in case of an independent sample t-test? So independent sample t-test is like the hypothesis is that the population mean of the two groups are equal. And you can say that there is no difference between these two groups. And in this case, the population mean of the two groups are not equal. That is the alternate hypothesis. So now let's see how we. So the first question is, I have to check regarding the distribution of following parameters. And I have to compare their mean or median values across their smoking status. So for the convenience purpose, I have taken the categorical variable. In this case, it is an independent variable, is the smoking status. And I'll be checking all these continuous variable across the smokers and non-smokers. And before I move to this Jamovi showing, let me brief you regarding the Mann Whitney, because we are going to learn both the tests together, because in SPSS, the options are different, but in Jamovi, the same interface is there, whether you have to do a independent sample t-test or Mann Whitney test. That's why I'll brief you regarding the Mann Whitney also. So now what is this Mann Whitney test? So this Mann Whitney test, as we have seen, this is the non-parametric counterpart of this independent sample t-test. So again, we learn all these things. So like if there are many variables which are like normally they are not normal. In this case, like if you want to compare a mean value of any outcome variable across the two dichotomous variable, like maybe the mean SGOT in the alcoholic liver disease and non-alcoholic liver disease patient, but the value of this outcome variable is not normally distributed. So you can see there is a QQ plot here where you can see this is a skewed, it is not, the individual values are not across this diagonal line. So I can say that this is a skewed distribution. So in that case, I should not be using independent sample t-test. But again, I said that if it is not that much skew, if it is a little deviation, because we call it as approximately normal distributed. But this doesn't seem to be approximately normally. This is the highly skew. So if it is a highly skew and I cannot apply independent sample t-test, in that case, what will I do? So if I know that the variable of interest does not follow a normal distribution, like in case of survival, you will see there are various time of survival time that also doesn't follow a normal distribution, or beforehand we plan to compare the median of variable of interest. So in that case, we apply this Mann Whitney U test. So this Mann Whitney U test is used when the assumptions of t-test are not met. And it is a non-parametric test because we always say that this is a non-parametric counterpart of the independent sample t-test. So it arranges the sample data, and then we have to see the either mean rank. The option of mean rank is not there in the JAMOV. So you have to compare the median and interquartile range. So the research question could be again the same. There will be a one continuous variable, but again, we will replace median term with, mean we cannot use. So the research question would be, what is there any median SGOT levels? What is the difference in the population with alcoholic and non-alcoholic fatty liver disease? Then is the median post-operative pain, which we have measured by the visual analog scale, is similar for the surgical technique 1 and surgical technique 2? And then you can see the third, this is the same research question. Maybe this is a little different than like the median Apgar score of babies which are born through the cesarean section and through the vaginal delivery. So here again, you can see there are two independent group or the levels of a dependent variable, and we are calculating this median value of a Apgar score. So in this case, we have seen that this is the Mann Whitney U, where there is a scale variable. We want to compare the median of this value across two categories of a nominal variable. So the appropriate statistical test is the Mann Whitney U test, which is also known as the Mann Whitney test. And again, the assumptions are like dependent variability. There is a one dependent variable which should be measured either on ordinal scale or on continuous scale. So Mann Whitney U test can be applied for a ordinal level of data also, like pain scale, Likert scale. You must have seen we do a lot of Likert scale. So that also can be done in case of a Mann Whitney U. An independent variable should have only two categories, and there should not be again that independence of observation that is required here also. And in this case, dependent variables should not be normally distributed across the two categories, and the distribution should follow. Ideally, it should follow the same shape, maybe the both right or left skew, but even if it is different, you can apply the Mann Whitney U test. So in this case, you can see that this is the SGO order MI, and these are the two skewed 2Q plot. So in this case, since it is not normally distributed, we will apply Mann Whitney U test. This is one example when there is a skew, but both distribution are of different shape. So you can see we have learned that in the normal bell-shaped curve, when this is a skewed one, because this is not a typical bell. So you can see here, this is the right skew, because skew we measure with the tail. So it is going towards right, so it is a right skew. In this, you can see this is going towards the left, this male, and this female going towards the right. So this is a combination of right and left skew. So the null hypothesis is that the median of the two groups are equal, and the alternate hypothesis is that median of the two groups are not equal. So they are almost same. The only thing is like the assumptions. If the assumption of normality is not met, or if there are ordinal values in your data, you can apply. And in SPSS, we have got additional option of comparing the mean rank. And that option is not there in the JAMOV, but still that median and IQR is there, interquartile range. So we will go to this. I'll show the questions. I think I have shown it to you that I will take the independent variable as the smoking status, and the variable which I have to take, that is the SpO2 CRP. So maybe you can move all the variables together. So what options will I use here? In analyze, you can see there are options. This exploration we have used in day 1 in descriptive. This we have used yesterday, frequencies, when we learned the chi-square goodness of fit, and we learned the chi-square test of association, homogeneity, Mac-Nehmer test, and we learned the odds ratio and relative risk. And then this is the regression. We learned this on, I think, yesterday only, that correlation matrix. These we are not going to cover. And we are going to cover this t-test and ANOVA today. So if you click this t-test, you can see there are three options. Independent sample t-test, paired sample t-test, one sample t-test. One sample t-test also I'll tell, but right now we are focusing on independent sample t-test. So you click on independent sample t-test. Now what will I do? You can see the two boxes here. This is the dependent variable, and you can see there is a sign here. So this is a sign of scale variable. So you have to move the scale variable in this box, and this is the grouping variable, and this should be either nominal or ordinal. So grouping variable in my case is the smoking status. So I have moved this to this grouping variable, and this dependent variable is the SpO2. So I'll start with this SpO2, then CRP level, C-reactive protein, CRP1. Next is the hemoglobin. So let me see, where is the hemoglobin? This is the hemoglobin. And then cortisol, LDH, and ferritin. So this is the, let me see the variable. This is the cortisol. The next is your LDH. And then it is the ferritin. So I have to check these continuous variable. So now what should I do first? So first you go and check for the assumptions. That's why I will move directly here. Don't right now focus on this independent. You can uncheck this right now. Uncheck this so that it will disappear. But by default, this value comes. So maybe then we can leave this. And then you can see here, come to assumptions check. So in SPSS, we used to do it. In SPSS, it gives you as a byproduct of the table. It comes like homogeneity, it is there along with the output. But here you can check it independently before you choose to wish, or before you wish to choose what, like you want to take the Welsh tea or you want to take the student tea. And in here you will see there are various three options. So in test, there is a student test. This we apply when the data is all those assumptions normally distributed, less number of outlier, and when the assumption of homogeneity is met. This Welsh you use when the assumption of homogeneity is not met. And this Mann Whitney you use when the data is not normally distributed. Now I will see, so I will click two things here, homogeneity and QQ plot. Homogeneity is one assumption and QQ is one assumption. For the outlier again, how will you check? You have to go back to exploration and you have to check for the outlier also. So assumption, if you see this homogeneity of variance, can you type in the chat box which variable is not, this assumption is not met. Homogeneity of variance assumption is not met for which variable? So yes, you are right, it is the SpO2. Why it is SpO2 is not normally distributed here?
Less than 0.05.
Yeah, because it is less than 0.05. And we have known from our previous learning that if the p-value is less than 0.05, it will not be following the assumption of homogeneity of variance. So then what should I do? In this case, what test should I apply out of these three options for SpO2? I'm asking. Please type in the chat box whether I should apply student or Welsh. Welsh. Okay, right? And then come and then you have to comment on the QQ plot. So you see this, then this CRP. You can do this in the exploration also, because there the box plot and QQ plot will come together. So then that task is, I think you can do it there also. So which variable you think is not normally distributed? See this SpO2. Then you can see this CRP. You can see this HB1. You have to see, the assumption was if it is approximately normally distributed, you can apply t-test. This cortisol, this LDH, and this ferritin. So based on your observation of QQ plot, which variable you think that it is not normally distributed? I'm again showing you the QQ plot. This is the SpO2, ferritin, LDH. Yes, two are absolutely right. Because if you see this LDH, it is definitely very much away from normality, and this ferritin also. Otherwise, if you see rest of the graph, it is approximately normally, like most of the data point you can see, it is normally distributed. Here also CRP is approximately normally distributed. So these are the two values, LDH and ferritin. So in that case, what should I do? Which test out of these three options, which test I should take? Please type in the chat box, Mann Whitney, you. Yes, right. And before I go to, because in the assumptions you have to comment regarding the box plot also. So you have to come here and I'll transfer all these variables here also. So maybe this SpO2, then cortisol, then this CRP, LDH, ferritin, and come to the plot. So you see this option of plots. I have to, maybe box plot you can click. So if you see the box plot, you can see there are no outlier in this box plot. In cortisol also no outlier, CRP also no outlier. There are few outliers, maybe 4, 5 in LDH, and there is again 5 outlier in ferritin. So now out of 180, I may decide to take, yes, hemoglobin also, right, Ria? Sorry, I forgot hemoglobin. So it is hemoglobin 1. This, sorry. Again, it has to be checked, this outlier that is there, but this has to be checked across the independent variable. So independent variable in this case was smoker, sorry. It has to be split by this, then only you can check. Now you have to check, because you have to check in each and every so yes, this is yes, sorry, and thank you, Venkatesh. I could see that that screen got freezed. So now can you see my screen? Am I audible now? Okay. Is still there is a lag or it is okay? Okay. Thank you. So can you see this? So we have to plot it across the independent variable. That's why you will see this outlier in the category of no smoker and in the category of smoker. Similarly, for cortisol also, and you can see the number of outliers. So if you have splitted it, see the number of outlier, it has decreased, because now it will be redistributed to both the categories. Here also you can see one outlier in this, and there are 5 outliers in no smoker category. There also you can. Okay, so that's maybe I'm switching off the camera because that may improve the this voice situation. So you are writing, Sarosh, outliers only in smoking to be considered.
Yes, ma'am.
Yeah, outliers only in smoking to be considered. No, in non-smokers also, like you can see here. This is the smoker. This is smoking status no versus yes. So you have to report the outlier that there were 5 outliers in the no smoker category and there were 1 outlier in the smoker category. So considered means I did not get your question. What do you mean by considered?
Like we're checking only in the smokers whether it is outliers are there or not. Only that.
No. In both the
So to
groups,
mention
because
for
there
both.
are 2 groups. There are 2 groups.
Okay.
You have to check in both the group. That's why it has to be done across group. Initially, I did a mistake. I did not put the smoker. So it was coming overall. But you need to check it across the group because we are doing the independent sample t-test. That's why you have to check the outlier in both the groups. And you need to report maybe numbers are very less. They are not too much. So you can only report that there were a few outliers, maybe 4 to 5 in one group and there were none in the other group. Similarly, you can report because in assumptions, while writing assumptions, you have to write this. And this time, I think we have yesterday we could not give you the template, but today we will give you the template also for writing the result. So all those we have made the template like independent variable and dependent variable. And then you can replace your variable with the same one. Otherwise, all the assumptions you can report. That means what all needs to be reported, it will give you a glimpse of that.
It will be very helpful. Thank you, ma'am.
Yeah, today we will give you about the yesterday session also. Not the yesterday, the rest of the 2 days, because we could not give. So those 2 days also we'll share. But today is definitely we are through. So we'll share it today itself. So this was the one, this was the assumption. Now coming to this independent sample t-test. So again, I'll go up and I'll again click this one, then this, once you click the output, then this, the previous window will be active where you left. So I don't need to go back again and put this independent sample t-test. I'll go just up in my result section. I will click this window will be active here. So now what will I do? So I have checked for the assumptions and I have checked regarding the normality and outlier. Now I will apply the test. So for that, what I'll do, I will remove this SPO2 because this SPO2 is homogeneity of variance is not met. So I need to do it separately. And again, this LDH and ferritin also, because they are not normally distributed. So I have moved them also back. Now this LDH has gone. Now these are the 3 variables which are normally distributed and they are meeting with the assumption of homogeneity of variance. Now I can go ahead with that student t-test. So the table of these 3 will be, you can club the table together and then you can click this mean, show the mean difference with its confidence interval, the effect size and the confidence interval. I will talk about the effect size, just wait for a few minutes. And then this is the descriptive and the descriptive plot. So this assumption coming to this, you can see here, this is the t statistics and this is the value of t statistics. This is the p value. So if you see the p value, you can see here that none of the variable is significant. There was no significant difference because you can see here that although there was mean difference, but the standard, this 95% confidence interval, you can see here minus 18 to 39, minus 2 plus. So all these are sign are changing and 0 is coming in between. That's why it is not significant. And then you can see the Cohen D. So now what is this Cohen D? So Cohen D is a measure of effect size. Now what is this effect size? As a in statistical term, when we measure the difference level, so in numerator, we have the difference of the 2 mean, and in denominator, you have got the standard deviation. So that is the Cohen's d or the effect size. But how do we interpret it? So the interpretation is basically like we did for the Kramer V. Can you recall the yesterday session when we did the effect size using the phi and Kramer V? When we learned that up till 0.2, 0.3 and 0.5, then we used to call it as a small effect size, moderate or large effect size. So what do we actually mean by this effect size? Strength of association. Yes, very right. And in this case, especially for the clinician, like if there is a difference, maybe if the in this case, if the CRP value between smoker and non-smoker, if the value, there is a difference of only 1 unit. When you increase the sample size, if you take 800 people, even the difference of 1 unit will be highly significant, because the significance level depends on the sample size also. You keep on increasing the sample size, the non-significant thing also becomes significant. But this effect size tells you, because this effect size is independent of sample size. So this effect size will tell you whether the statistical significance which you have got, does it make any clinical significance or not? So this tells you regarding the clinical significance. Like whether the 1 unit change in CRP, is it a clinical significant thing which should be noticeable by a clinician or not? Are you getting my, am I making sense to all of you regarding this effect size? So the effect size is emphasizing regarding the clinical significance or the actually practical significance, because statistical significance, always it is not very helpful. When you practice the medicine, when you practice the evidence-based medicine, then the concept of effect size is really important. That's why these days journals, they are especially asking for effect size, because that is ultimately it will go into the practice. Even if something is 0.000 highly significant and the effect size is less, it is not going to be in the policy level, because the clinical significance is not that much. Again, here also it is like 0.3, 0.5 and more than 0.5. So if it is up till I think 0.2, 0.5 and more than 0.5. So if it is up till 0.2, you call it as a small effect size. If it is up till 0.5, you call it as a moderate effect size. If it is more than 0.5, you call it as a very high effect size or very good effect size. So that is, in this case, you can see you express it with the 95% confidence interval also, but you will see here that all the effect size was very less. So effect size, basically, although you report it, but you comment when there is a significance. If there is no significance, then there is not much use of reporting this effect size. Am I audible, or still there is some voice issue? Voice issue. So should I change? Okay, is it okay now? Okay. Yes, today I think there is some issue with the connectivity. It is going on and off. So I'm sorry for that. So should I repeat any concept till what time? I think, did you get this effect size, the concept of effect size? So in this case, this was the effect size, and we were focusing on this effect size. And you can see here that all the values are like, in this case, only the second one is 0.27. So it is a little okay, like 0.2 to 0.5 is the moderate. But still, because it is not significant, you will see the confidence interval also, it is not significant. So you have to report for the 95% confidence interval of the effect size also. And then coming to the other reporting. So if you see then you have to comment on the descriptives. So if you see the descriptive, this is the Levine's test of homogeneity of variance, which we have seen initially. And then this is the group descriptive. That means this shows the number of people who are there. This no is for the no smoker and 57 is smoker. 123 and 57. The mean value of CRP in no smoker is 152, whereas in smoker it is 10 units less. Similarly, median is also reported with the standard deviation. In hemoglobin also you can see here that 9.37 is the mean hemoglobin in non-smoker, whereas people who are smoker, they have reported less hemoglobin. Similarly, the level of cortisol, the people who were smoker, the levels of cortisol was more, but the change, the difference was not significant. And then there is another table where you can see this one. So you can see here the mean difference. So this is showing the difference 10.27, 0.58 and 0.673. And this minus tells you in which group it is more or less depending on that. So it is minus because you can see here that in the third one, in both the cases, this yes, it was less. Yes was less. But in this case, yes was more. That's why what it does, it reduces the yes means whatever you have coded 1. So 1 minus 2. That's why all these are positive differences, which is there. In SPSS, it gives you like I minus j. But here you have to see from the table of descriptive. Like it is whether the 0 minus 1 or 1 minus 0. Are you getting my point about this plus and minus sign? Are you guys are with me? One of you, please, you can text yes or no. Okay. Then you can come down. And this is the mean plot. We call it as a descriptive plot. So it is you can see this is the mean of the two values with 95% confidence interval. And then this is the QQ plot. This is the mean plot of hemoglobin. So you can report these things in your maybe thesis or in your project. So I said that this gives you very beautiful diagram. You can incorporate these into your this thing. And again, you can change the view of this also. Like I told you, you can go here, this 3 dots. Here you can see plots. So plots, you can plot theme, you can see, you can, if you do it minimal, and then if you stop it, you can see there is a it is taking, yes, you can see the look of the graph, it has changed. There's a one more option like I love SPSS. So if you do it like that, then the graph appearance will be like SPSS. Similarly, Hadley. So these are the options. So maybe I'm again going back to default. So you can change the look, maybe that color also you can change here. You can say color palette. It is there. So right now, maybe it is the Jamovi I have kept. You can change the color scheme also of the graphs. So this was regarding the independent sample t-test. Anything which you want me to report before I go to the Welsh and Mann Whitney? Anything you want me to repeat or anything which you have not understood? Then you can even unmute yourself and ask. Is it okay up till this point? Please say yes or no. Okay. So I'm taking your okay as a proxy okay for everyone. Thank you. So I'm going again now for, I will move these variable back to this window and now I'll do SPO2. SPO2. So what was the problem with SPO2? Why we could not do the student t-test? Because the homogeneity of variance was not there. So what I'll do, I'll go to this Welsh and I'll uncheck this. So in this case also, you will see the value of t statistics. We will take the Welsh t. So this is the homogeneity of variance, which is not met. This is the descriptive like mean. And if you see the value here, come down, this is the mean plot. And here you have to see the mean difference descriptive. So I have to go up. This is the SpO2 and Welch T statistics is 3.36 with 77.8 degree of freedom. And you can see it is highly significant. And there was a difference of 2.86. So SpO2 level, there was difference of 2.86 in smoker as well as non-smoker. And here you can see in smoker, this was less. And in non-smoker, this was more, the SpO2 level. So smokers, the SpO2 levels were, you can write 2.6 unit more than the non-smoker. And it's 95% confidence interval. You can see here that the confidence interval doesn't have zero. So both the upper and lower are above zero. So with this confidence interval, if there is a difference, then we say that the two extremes should not have zero in between. Like in case of an independent sample, paired sample, we say that it should not have both positive and negative value. In case of a ratio, like odds ratio, and when there is a ratio, we say that it should be not having one in between. So remember, 1 and 0. If it is if the outcome is a difference, we say that 0 should not be there between the two values of confidence interval. And if it is a ratio, we say that 1 should not be there. Is it okay? So now you can see the graphs also. This is the mean. Only the SpO2 is there. So this is the mean plot and this is the you can see here. So if it is highly significant, you will see that the confidence interval of these two, they will be entirely separate. There will be no area when this value and this value will coincide. So from the descriptive plot also, you can be doubly sure that this is highly significant, because all these values, when it has ended, the other value, it has started here. So none of the values, like its confidence interval value also, it is not like overlapping. So this descriptive plot helps. Am I audible? There was some.
Yes, ma'am. Yes, ma'am.
I'm sorry, I don't know why. Can you see this descriptive plot? So this descriptive plot, if it is a highly significant, then none of the values, because this is the mean and this is the confidence interval, all these values. So they will be entirely separate. It has ended up till this, and then this value has started in no. So if there is no overlap of the values, then you can say that it is highly significant. So this descriptive plot also helps you to understand whether difference is highly significant or it is just significant. If it is just significant, borderline significant, then you might see some of the values where they are overlapping, the two groups. But here, because none of the values are overlapping, so you can say that it is highly significant. That's why it is minus 0.001. So this was regarding the Welch. Now we'll go to the Mann Whitney U. So for Mann Whitney U, I'll again move this back to here, and then LDH and probably the ferritin. So I'll move this LDH and ferritin in this, and then you can see this is the LDH. So again 123 and 57, and in this case, since the this homogeneity of variance was met, so again I will not use neither of these two. Rather, I go for this Mann Whitney U. And in Mann Whitney U, since there is no point of this mean difference because it is size maybe. So you can see group descriptive. This you can see the smokers, this mean and 95% confidence interval. And you can see descriptives. Mean difference. This is the median, 927 and 925. This was 988, 66 and 848. And interquartile range it doesn't give. So you have to go to that exploration and do that interquartile range there. And this ferritin also, these two are the median values. And then there will be value of Mann Whitney U. So the Mann Whitney U, this is the Mann Whitney U value. With LDH, it is the 3482, and with ferritin, it is the 2823, and the p value is not significant in this case. So you can see that this is these two things you have to report, statistics and p value, and in this case, it is not significant. So if you have to write the interpretation, how will you write it? So like this is the table. You can enter the values like we have written here. This is the IV is for the independent variable or for the grouping variable, and this DV or this is the dependent variable. So depending on whether you want to take 1, 2, or 3 or n number of dependent variable or the scale variable, between you have to report the descriptive in the form of mean and standard deviation. Between these two groups, you have to write the value of T or the Welsh T. T can be student T or Welsh T depending on the value of Levine statistics, its degree of freedom and p value. In the footnote, you can give these values, and then you can write the description that there was n1 number of cases in the first level and n2. So in this case, it was 123 and I think 127 and 23. If you see the n, 123 and 57. So you can write here that there was 127 cases in the non-smoker and 57 in the smoker. And then you can write that the dependent variable, the mean value of these two across level of the independence, IV is for the independent variable. Where normally distributed, this we are writing as an assumption. Normally distributed as reported by the visual inspection of QQ plot to test for the normality, or you can write that it was not normally distributed. And you can write that there was either no outlier or there were few outliers as evidenced by the visual inspection of box plot. An independent sample t-test was run to determine if there is a difference in the mean values between these two levels. And there was homogeneity of variance met or there was no homogeneity of variance. Depending on that, and in the bracket, you have to give the p-value of these homogeneity of variance Levine statistics. And we observed a statistically significant difference or no difference in mean value of these whatever you are doing across the two levels. And then you have to report the mean and standard deviation along with its p-value. So this is the write-up. You can replace the appropriate variable which are of your interest. So again to this independent sample t-test. So in this paragraph, I have written regarding the assumptions. So I have mentioned regarding the visual inspection of QQ plot. I have mentioned regarding the outliers in the box plot, and I mentioned regarding the Levine statistics. So these three assumptions you have to write. Whether it was met or not met, depending on that, you will report your result. So this was there, and then you have to write the descriptive also. Like in descriptive, you have to write here that there was this much. So we observed a statistically significant difference or no difference. There can be a difference, but it was not statistically significant, like we have seen with the first three example. In the mean value of, and this is the dependent variable. That means whatever the continuous variable you are taking, this is that of patients having the levels of two categories of the independent variable that you have to write. Coming to the Mann Whitney you have to write the median and interquartile range, and you have to write the value of Mann Whitney U along with its p-value. And here you have to write that it was not normally distributed as seen by the visual inspection of QQ plot. There were significant number of outliers which were either kept or removed from the analysis, or then you have performed this Mann Whitney U test, and then you have seen that there was a difference in the median value. So median value for the first dependent variable for the first level of independent variable was this. Like in this case, you can write LDH. If, for example, LDH, you can write that the value of LDH in smoker was this, and the value of LDH in the non-smoker was this, the median value, which was statistically significant or not significant. So in this case, it was statistically not significant. So generally, yes, in case of a Mann Whitney U test, because you don't remove the outlier Or you can do that. It is not necessary. You may take a call to remove and again do a normality. Because even if after removal of this outlier, still the data is not normal, you have to do a Mann Whitney test. Okay. So if you plan to remove outlier, you should again retest all the assumptions after removing the outlier. And then you can come down. So no, this was for the first, before we go to the first breakout room. So any query which you want me to, or commands. So if, let me summarize the commands once again and everything. So we have read three things here in this session. We have seen the student t-test, Welch t-test, and Mann Whitney u-test. So before we apply the test, we see the assumptions. So we first come down, we see this homogeneity test and QQ plot, and box plot you have to see from the exploration option. You check for these three assumptions, and then what you do, you apply the test. So you move your dependent variable, in this case, in this one, in this box, an independent variable to this box. If you plan to have all the variables together, you can first move it here, check for the assumptions, and those variable which doesn't satisfy either the homogeneity of variance, you can remove and again do the student t-test, and then again you can do the Welch t statistics for variable who are not meeting the assumptions of homogeneity of variance. And in case the data is not normal, नहीं, लेकिन इससे हमारा तो सिस्टम हमेशा ही हो रहा है. आज तुम्हारा एडमिन किक चल रहा है. So I was revising the steps. So you can see here that again, depending on the Levine statistics value, you can, if it is homogeneity of variance is not met, then you can use this Welch. So now any query which you guys have, then I can solve that. Otherwise, we'll go to the breakout room.
Ma'am?
And yeah.
Thank you. Can we identify the outliers in this by using the software, madam?
Yes, actually in this case, in SPSS, it is very easy because it gives you the number, which is the outlier. Like for example, if you come to this exploration here, or I'll go up where I have maybe drawn some box plot. Yes, in this case, can you see? This is the outlier. Okay, so it is not possible for me now to know which is this number. So I'll go with these values, maybe approximately. So values which are more than 2000, these are the outlier for me. And in smoker, the values near 1600, this is the outlier for me. But in SPSS, it tells you the exact ID number of the patient. But there are two versions of GEMOV. Remember, there is a current version and there is a solid version. Remember, when you installed the GEMOV, you installed which version?
Solid version.
Solid, yes. So if you install a current version, this option is there in current version. But after, I think they first do it all the options, because it's a newly developed software. So they are incorporating all those things after getting the feedback. So they have incorporated this option in the current version, and it will come into the solid version also, maybe after few days or weeks or months. But currently it doesn't have this option.
Okay, ma'am.
You can do that. You can arrange the data in maybe ascending order, and then you can remove, because values are clear here, that all these values are more than 2000. So you can then remove all these outliers.
Thanks, ma'am.
Okay. Any other query? If not, yeah.
Sorry. In this box plot, how do we interpret this median line? Like we have this, not only for checking for outliers. If we want to also see the median and the line that we have here, can we comment on that also, madam? Sometimes the line will be very lower, not in the middle of the box.
This one.
below that one, and then within
This
the
one,
box,
smaller and
within the box.
this horizontal.
Yeah, madam.
Yeah, actually, this is the median, and this is
Right.
the Q1, and this is the Q3. Means
Interquartile
it is
3.
the interquartile. This whole is the Q1 and Q3, and this is the median value.
Right, madam. Got it.